Assalamualaikum, my name is Noraina binti Helmi. My matric number is 191200507 and I'm from group B4. This video is about our e-poster file analysis project. There are a few parts in our poster and I'm going to talk about introduction part, objective part and equipment part. Introduction. We have conducted an analysis on file bearing capacity and factor of safety. By using the site investigation report data that we obtained, it is a report on site investigation work at Kallang Pudding Road. This report represents the site investigation work at Chow Chu Kang Drive. Site investigation at the site started on 20 December 2007 and finished by 27 January 2008. There are 3 bar log attached in the report, but we have chosen only 1 bar log to conduct our file analysis using Excel sheet and Plaxis software. Objective. Our aim in conducting this file analysis is to explore and utilize our site investigation data in order to find file bearing capacity and factor of safety. Equipments. There are 2 software we use in this analysis, which is Excel sheet and Plaxis software. The reason we use this software because it is easy to use and accurate. Plaxis is the leading geotechnical engineering simulation software developed specifically for deformation analysis of soil and rock. Renowned for ease of use and accuracy, it helps us optimize our design more effectively than applying traditional conservative population method. Besides, Excel helps us by recommending and then automatically creating pivot tables, which are a great way to summarize, analyze, explore, and present our data. A pivot table may be used as an interactive data summarization tool to automatically condense large dataset into a separate concise table.
Okay, for manual calculation, in order to find Q ultimate, we are using menu of method in SPT. But the first thing, we need to know the value of N60 first so that we can substitute it into the menu of equation in order to find the QP. The FFV value for height displacement driven file also need to be calculated. Then the value of end bearing capacity QP can be calculated by using the step 6. And then the highest value of shaft friction QS and the end bearing capacity QP that finally can be calculated in order to find the Q ultimate. The Q allowable, Q all also can be determined by divided the value of the Q ultimate with the factor of safety that equal to 3. Okay, for the Plaxis software is quite long, so I will make it short. First, we create plate element, then we select plate command and insert high influence area. Then we select geometry line command and define various soil layer. In the step 4, we assign natural data to respective soil and structural element. Next, we apply initial condition and update calculation. Define groundwater level and define phases so that we can generate mesh. Then apply load at the pi nodal point so that we can analysis of the result and the result will come out.
Assalamu alaikum wa rahmatullahi wa barakatuh. My name is Abdullah Saleh Abdul Wazir. I am from RKO01, third year student. Today I would like to talk about our OL experiment. This sample was taken from Kallang Pudding Road. As you can see here, the location, the starting date, and the date completed. Here is our type of soil. We have three layers of soil: silt and clay and sand. And here's the parameter of our soil based on SI report. Based on what data we have given, we need to use the Mayer-Horf method for correlated with SPT and value. Here is the formula, and this is for QP. And for QS, we will use the same for Mayer-Horf method with for SPT and value. This is the formula. Here is the formula for finding N60 and N correctly 60. And for the above value, we assume it here based on this table 1.1. After that, we plug all the formulas on this table for depth and the difference length and type of soil, SPT and value, N60 and N corrected 60. We found here, we do the checking. Suppose this one to be bigger and this one, all of it is okay. And we found the value for QB and F average, and after that we found the frictional resistance, and here the ultimate bearing capacity. After that, based on this, for the total point bearing capacity, bearing for here for total point bearing, this one we get it from this one, and for QS from here. For Q ultimate we will plus this value and this value. And after that, for factor of safety is 3, and we just divide this one, we'll divide it by 3, and we will get this value. That was my time, and thank you.
Hi everyone. Today we are going to talk about the Plaxis analysis. Currently, we are using Plaxis 2D to analyze the power bearing capacity QU. For information, Plaxis 2D is a geotechnical analysis software which can use to determine the total displacement, effective stress, total stress, and so on for the soil. But today we are focused on the power bearing capacity. First, we need to draw the model of power and divide the soil into several layers as shown in the figure based on our SI report. Next, we need to input the estimated bearing capacity value from previous manual calculations and others required components such as groundwater level, unit weight of soil, and so on. After that, we start to calculate. So, by generating deformation mesh, it shows the deformation occurs due to the reaction and soil stress in the soil, as shown in the figure. So beside that, we can also find that the total stress reacted on the pile as shown. If you are not satisfied, you may refer to the table to check the stress at particular point. In our analysis, we trace the vertical total stress, sigma yy from soil at bottom of pile and multiply it with the affected area of pile to obtain the point bearing capacity QP. Meanwhile, we trace the horizontal total stress sigma xx from soil also at the different layers of soil reacted onto pile multiply by the affected area of the pile separately for different layers to obtain the frictional resistance Qs. This is the flow of the whole calculation. So after we obtain the Qs and Qp, we summing up the value of Qp and Qs to obtain the power bearing capacity Qu. That's all for the analysis. Thank you.
Assalamualaikum and hi. My name is Muhammad Ashraf bin Ibrahim. I am from group B4. Today I want to present about the result and the discussion. This is the picture of the deform mesh of borehole log after we calculate and we transfer the data into the Plaxis software. The discussion, we can determine that the soil contains silt, clay and sand at a depth of 20 meter based on data from the SI report in the borehole log. We can retrieve the result of the deformation soil, total stress, total strain, and other factors that are involved in pile and foundation building utilizing Plaxis software. The overall displacement for the pile is 744.28 times 10 to the power of negative 6 from the surface, according to our distorted mesh result. As a result, the pile was deep due to soil that could not sustain the complete bearing capacity applied to the pile, and the sand was also too soft for the pile. The total stress around the pile was the highest, particularly at the lowest part. Finally, because of the groundwater level is near the soil surface, we can assume that the majority of the soil is saturated. Thank you.
In conclusion, the objective of analyzing pipe bearing capacity using Plaxis software or Excel sheets are achieved, and the measuration is found to provide reasonable accurate results. The value of ultimate bearing capacity to estimate by the Excel sheet is 2,269.76 kilonewton, while Q ultimate that generated by Plaxis software is 246.24 kilonewton. So the percentage error of Q ultimate between these two software is 89%, which is quite high. It's because Plaxis does not have determined the exact solution, because if it would be able to determine the exact solution, then we will not need a tolerate error. So besides, Plaxis try to reach equilibrium between the sum of the internal forces applied to the models like loads, weights, and the integral of internal stresses in the soil and structural element. So let's say the extreme total displacement that we get from the Plaxis software is about 744.28 times with power of negative 6 meter. That's all from me. Thank you.